Hello, my name is John Broadwell, and I'm an embedded systems and medical device development consultant at my company, Broadwell Consulting Inc, and the creator of the open source Serial Wombat project. Today we're going to be expanding on the previous Raspberry Pi/Python video that we did. You can see a link to that up above here if you haven't watched that already. And I should let you know that the chip that we're looking at today and the dev board are not yet available. If you're watching this in the spring of 2022, you should know that our Kickstarter campaign will be kicking off on April 11th. And that will be the first and only for a while source for getting the Serial Wombat 18AB chip. Eventually we'll get to Amazon, but for right now we're going on Kickstarter. You can find a link down below to that Kickstarter campaign. What we're going to be looking at today is, instead of the prior video where we used I2C, we're going to be connecting to the Serial Wombat 18AB chip through UART over an FTDI cable connected up to the USB port. So we'll go through the steps for initializing that and then run a simple sketch that measures distance using the ultrasonic sensor distance mode on the Serial Wombat 18AB. Let's get started with that. Let's plug in some hardware. What I've got here is a Serial Wombat 18AB carrier board that's been soldered together for UART use. We've got the FTDI header on here. I've got all my support components in surface mount form on the back, and I added a USB 5 volt to 3.3 volt LDO. That's an optional component that's not included in the kit. Let's plug in here. We're going to put the black cable next to the arrow. That's all ready to go. And then let's plug in the FTDI cable to the Raspberry Pi. Okay, now that our device is plugged in, let's take a look. We'll do an ls-l/dev. And what do we see? We're looking for TTY USB 0, which is right here. Now we'll note that it has added that to the group dial out. That's going to be important in a minute. Let's take a look at as to why. We're going to go ahead and open up Thani again. And what I've loaded here is the file Serial Wombat UART example.py. And this is the same example we looked at in the last video. And here, except here we can see, instead of creating a Pi GPIO instance of the Serial Wombat chip, we're going to create a Serial Wombat chip UART. And we're going to tell it we want you to use dev TTY USB 0. That's the FTDI adapter that we just plugged in. So let's run that. Denied. Specifically permission denied. We do not have access to, we don't have permission to access that TTY. And the reason for that is that John is not part of the dial-out group. So what we need to do to fix that is sudo usermod -a for append -g for group dial out and user, that's me. Add our sudo password there. Okay. Now I should be in the dial out group. In order for that to take effect, I'm going to have to log out. And log back in. And we'll hit go again. And this time it worked great. We found our Serial Wombat 18A chip. It's saying A because it's connected up to UART. It would say B if it was connected up through I2C. And at this point, we are pulling in our various values. Okay, let's walk through our sketch. This assumes that you ran the installation routines from the I2C Python video that I mentioned earlier. So we're going to import time so we can do delays. We're going to import Serial Wombat UART, which is a version of the Serial Wombat chip that has UART interface routines. And we'll import Serial Wombat ultrasonic distance sensor so we can do ultrasonic distance sensing. We will instantiate a Serial Wombat chip using Serial Wombat UART.Serial Wombat chip UART, and then we'll provide it with the port name /dev/tty USB 0. We'll start it up. We'll say don't do a reset. And then we will query it for the version, model, and firmware version that'll print out down here. And then distance sensor, let's instantiate a distance sensor, Serial Wombat ultrasonic distance sensor.Serial Wombat ultrasonic distance sensor, kind of a mouthful, but it's descriptive, with a reference to that Serial Wombat chip that we instantiated earlier. And then we'll just say distance sensor begin. We're using an HC-SR04 based ultrasonic distance sensor. You can get those easily on Amazon or wherever. That's driver number 0. That's the only driver right now that this pin mode supports. May support other chipsets for ultrasonic distance sensing in the future, if that's something people are interested in. We're going to hook up the echo measurement pin to Serial Wombat pin number 10 and the HC-SOR4 driver to Serial Wombat pin number 11. And the pull-ups and auto-triggering will leave set to their default values. At some point in the future, there will be another video that talks in depth about the ultrasonic distance sensing mode. If there's a tag above my head, then I've created one. If there's not, then I haven't yet. So we will print out our source voltage just kind of as a sanity check. We'll wait 2 seconds, and then we'll go into a loop where we just constantly ask the Serial Wombat chip, what is the distance? And that chip is constantly pinging, listening, and measuring the pulse. Then as soon as the pulse finishes, the next millisecond or two, it starts another pulse. So it's constantly measuring, and we just happen to be querying it for the latest measurement. It's also possible to set it up so that it doesn't auto-trigger and you only ping it manually occasionally. There's some use cases where you might want to do that. So we're just going to hit go here, and we got our source voltage, and great, this is running. Let's go over and take a look at the hardware. Okay, we're looking at our Serial Wombat chip here. We've got our ultrasonic distance sensor. As we said, we've got the measurement pin on 10, the pulse pin on 11, and we're hooking up and making use of the 5-volt sensor here on, we're using the 5-volt power supply coming from the USB because this ultrasonic sensor really prefers to have 5 volts rather than 3.3. So we can see we got it lined up about on the 7-inch line. If we put this here, that should be about 75 millimeters, 100 millimeters, 125, 150 roughly, and then back again should be down to 75. So as you can see, that's working pretty solidly, and we've connected up and are now doing ultrasonic distance sensing over USB to UART to Serial Wombat chip to ultrasonic distance sensor. So if you have any questions, leave them in the comments below. I hope you found this informative, and I certainly hope that if you're watching this in the spring of 2022, that you'll head over and back the Kickstarter project. So as always, questions, leave them in the comments, and let me know what you're working on. I love to hear the use cases, the applications that you guys are using the Serial Wombat chips for, and that really does help focus me on what additional improvements or bug fixes or functionality or libraries or whatever get worked on next is based on what is being used in the field. I make stuff because I like you guys to use it. So anyway, keep having fun and keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Inc. Broadwell Consulting Inc. provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.